From the drawing board, it promised to redefine military mobility. A vertical takeoff and landing aircraft, yet capable of fixed wing speeds. It was a vision of the future, a marvel of engineering complexity designed to bridge an impossible gap. But the V-22 Osprey, for all its revolutionary potential, carries a darker narrative. A shadow. A persistent question that echoes with every incident, every headline: why? Why does this incredible machine, this titan of innovation, continue to fall from the sky? We're about to delve into the shrouded truth, counting down the layers of the enigma. Coming in at number 15, we confront the very foundation, the ambitious design premise. From its inception, the Osprey wasn't just another aircraft, it was a radical idea, a concept that defied conventional wisdom. It aimed to merge the best of two worlds, the helicopter's agility with the airplane's speed and range. But combining these seemingly incompatible flight regimes required unprecedented compromises, pushing material science, aerodynamics, and control systems into uncharted territory. Was the dream, perhaps, too grand? Too fundamentally challenging to ever be truly tamed? At number 14, we encounter the expedited program timeline. Revolutionary projects often demand time, meticulous testing, and iterative refinement. But the Osprey arrived in an era of urgent operational needs. There were whispers of accelerating deployment, of pushing the envelope faster than perhaps prudence dictated. This pressure, an invisible force, seeped into every phase, from design validation to initial operational capability. Did the ambition to field this unprecedented capability quickly introduce complexities that later manifested as critical vulnerabilities? A question that hangs heavy in the air. Sliding in at number 13, we uncover the diverse operating environments. The Osprey isn't a museum piece, it's a workhorse, thrust into some of the planet's most hostile territories. Deserts with abrasive sand, humid coastlines with corrosive salt, icy mountain peaks where air thins and demands soar. Each environment presents its own unique crucible, relentlessly testing every component, every system. What happens when a sophisticated machine, already operating on the edge of innovation, is subjected to these ceaseless, varied assaults? The answers, sadly, are often written in wreckage. At number 12, we glimpse the challenge of the specialized supply chain. Maintaining a revolutionary aircraft demands revolutionary logistics. The Osprey isn't built from off-the-shelf parts, many components are bespoke, custom-engineered for its unique demands. This creates a delicate ecosystem where availability, cost, and timely delivery of specialized parts become mission-critical vulnerabilities. A single, custom-forged component failing can ground an entire fleet. How does this intricate dance of bespoke parts contribute to a hidden fragility? The answer lies in the complex web of global manufacturing. Our journey continues to number 11, the intense maintenance regimen. Keeping the Osprey airworthy is no ordinary task. Its dual nature, part helicopter, part airplane, means maintenance crews must master two distinct disciplines, often under demanding conditions. Every hour in the air is followed by numerous hours on the ground, a meticulous ballet of inspections, repairs, and diagnostics. Is the sheer scale and complexity of this continuous upkeep a source of hidden risk? Does even the slightest oversight, in such a demanding process, carry catastrophic implications? The questions multiply with every wrench turned. At number 10, we consider the human element, the unconventional pilot training. Flying a conventional helicopter demands mastery. Flying a jet, another skill set entirely. But flying the Osprey requires an almost schizophrenic command, seamlessly transitioning between two distinct flight envelopes. The learning curve is steep, unforgiving. How does this unique demand on pilot cognition and muscle memory factor into the equation? Are even the most experienced pilots susceptible to the inherent challenges of this revolutionary control scheme? The line between triumph and tragedy can be breathtakingly fine. Dropping to number 9, we peer into the mind of the machine, the intricate digital controls. The Osprey isn't mechanically linked to its controls, it's entirely fly-by-wire. Every input from the pilot is translated into digital signals, processed by complex algorithms, and then sent to actuators. This digital brain is meant to simplify control, but it also introduces layers of software complexity. A single line of code, an unforeseen interaction within the digital tapestry, could unleash chaos. How often do these silent, digital whispers contribute to moments of profound uncertainty in the sky? At number 8, we explore the ground effect quirks. When a helicopter hovers close to the ground, it experiences a cushion of air, known as ground effect, which improves lift. The Osprey, with its large rotors and unique downwash, experiences these aerodynamic interactions differently, sometimes unpredictably. This can create unexpected turbulence or a sudden loss of control authority during critical phases like landing or hovering low. Is this phenomenon, this hidden current of air, a more insidious factor than generally acknowledged, especially in confined or challenging landing zones? Coming in at number 7, a chillingly famous term emerges: vortex ring state vulnerability. This isn't unique to the Osprey, but its unique flight profile makes it particularly susceptible. It's a condition where the aircraft essentially re-ingests its own disturbed air, losing lift and entering a rapid, uncontrolled descent. Imagine being caught in your own invisible, downward spiral. For a tiltrotor, especially when transitioning or descending vertically, the risks are magnified. This insidious aerodynamic trap has haunted vertical flight for decades. Could it be a more frequent, silent contributor than we realize? At number 6, we examine the dual-engine synchronization. The Osprey flies with two massive engines, each driving a colossal prop rotor. But they don't operate in isolation. They must work in perfect harmony, their power delivery precisely synchronized, even during the most demanding maneuvers. Any discrepancy, any imbalance, can introduce violent torque, vibrations, and unpredictable behavior. What happens when this intricate dance falters, even for a microsecond? The forces unleashed could overwhelm systems, pilots, and structural integrity. It's a delicate ballet where any misstep has dire consequences. Delving deeper into propulsion, at number 5 we find the rotor power transmission. It's not enough for the engines to work in sync, that power must then be efficiently and reliably transmitted to those colossal prop rotors. This involves an incredibly complex series of gearboxes, shafts, and linkages, all designed to withstand immense forces. These components operate under extreme stress, generating significant heat and enduring relentless wear. A failure here, deep within the machine's mechanical heart, could lead to an immediate and catastrophic loss of thrust. The sheer brute force involved is staggering. Coming in hot at number 4, we arrive at the interconnected drive system. This is one of the Osprey's defining features, a shaft running through the wing that links both prop rotors. Why? So that if one engine fails, the other can still power both rotors. A brilliant redundancy, but also a massive vulnerability. This long, complex shaft, with its various couplings and bearings, is under constant, immense torsional stress. A failure in this system doesn't just reduce power, it potentially severs the lifeline between the two rotors, leading to asymmetric thrust and immediate, uncontrollable rotation. A double-edged sword, indeed. Breaking into our top 3, we face mechanical transition stress. This is the heart of the Osprey's unique capability, the miraculous tilting of its nacelles, transforming from helicopter to airplane. This isn't a smooth, seamless flow, it's a monumental mechanical feat. Gears grind, hydraulics surge, and structures flex under extraordinary, dynamic loads. Every bolt, every pivot point, every sensor is pushed to its limit during this critical phase. Could the very act of this metamorphosis, repeated thousands of times, be slowly, insidiously weakening the machine in ways not fully understood? And now, at number 2, we delve into aerodynamic transition control. The mechanical stresses of transition are immense, but so are the aerodynamic ones. During the tilt, the Osprey experiences a complex, ever-changing airflow over its wings and rotors. There's a crucial window where it's neither fully a helicopter nor fully an airplane, a delicate balance of control authority. Unexpected gusts, sudden maneuvers, or even slight miscalculations in this phase can quickly spiral into an unrecoverable situation. It's a dance on the razor's edge, a moment of profound vulnerability where the laws of physics are most dramatically challenged. Finally, at number 1, we reach the ultimate truth, the fundamental tiltrotor design itself. The Osprey is a compromise, a magnificent attempt to defy conventional limitations. But every compromise introduces new complexities, new failure modes, new sensitivities. It is a machine that operates at the very boundaries of aeronautical engineering. Its crashes are not merely isolated incidents, but perhaps inevitable reflections of the immense, inherent challenges of its core concept. The very brilliance that makes it unique also makes it uniquely vulnerable. It is the paradox at the heart of the V-22 Osprey. The V-22 Osprey, for all its undeniable capabilities and strategic importance, remains an aircraft shrouded in an enduring mystery. Its operational history is a testament to both human ingenuity and the relentless unforgiveness of physics. The crashes we've examined are not singular events, but echoes of a complex interplay, cutting-edge design, immense operational pressures, sophisticated engineering, and the sheer challenge of piloting a machine unlike any other. The Osprey continues to evolve, to be refined, but the fundamental questions, the inherent paradoxes of its very existence, will likely continue to spark debate for decades to come. What do you think? Is the promise worth the price? Let us know in the comments below, and don't forget to like and subscribe for more deep dives into the world's greatest enigmas.